Problems 1.1.1. So first thing we're going to do is go through the equations. So our first equation is IMA. And what's IMA stand for? Ideal mechanical advantage. So it's going to be effort distance over resistance distance. And this is something we didn't talk about in the notes, but this will be useful for problems. It's also equal to the ideal resistance force over the ideal effort force. So that'll be given if you want to figure out the maximum load you could possibly lift with this machine at a certain force, or if what's the minimum force required to lift a certain load. So these are the forces not including friction. And then we've got AMA equals resistance force over effort force, and those are both the actual resistance force and effort force. And last equation is going to be efficiency equals AMA over IMA times 100%. Everybody kind of remember those equations from the notes? Okay, I'll give you guys a second. Alright, so this is our first problem. So we have our lever here. That distance is 8 feet. The shorter distance from the fulcrum to the loader lifting is 2.2 feet. So A, what type of lever is that? First, second, or third class? Second. I remember first class is always just the traditional like teeter-totter lever. Second class, so I always think of second, like what you go to next is you still want to have a ideal mechanical advantage greater than 1. So second class has an ideal mechanical advantage greater than 1, so it's going to go through a longer distance out here. And third class has the mechanical advantage less than 1. Alright, so B, what is the ideal mechanical advantage of this lever? So we're going to say IMA equals effort distance over resistance, over resistance distance. Alright, so remember we talked about like the distances are actually if you went around like a big circle around these, but we don't have to incorporate the 2 pi part of it because that cancels out always. Does everybody kind of remember that? So we can just use the radius of the circle it would make. So we can use the length of the lever arm. So let our effort distance be here. No, remember this distance is measured from the fulcrum, so it's just going to be 8. So 8 feet. And what's our resistance distance? 2.2 feet. And what's that equal when you divide that out? .63. We'll just leave it there. And there are no units on this because we divided feet by feet, so those are going to cancel. So the IMA is unitless. I'm going to... I don't want to shrink the whole thing down. Alright, we'll just skip that. Alright. Any questions on part B there? Alright, so C. If the weight being lifted weighs 19 pounds, what is the ideal force that needs to be applied to lift it? So for this one, we're looking for the ideal effort force. So we're going to say IMA equals resistance force ideal. I'm just going to call that I over effort force ideal. So we found our IMA from before, so it's going to be 3.63 equals the resistance force is going to be 19 pounds over effort force ideal. So we'd multiply both sides by our ideal effort force, and we'd end up with FEI times 3.63 equals 19 pounds. And then divide both sides by 3.63. £19 divided by 3.63 for our mechanical advantage. And what's our ideal effort force? 5.23 pounds. So that's answer number C. Any questions about that one? I'm going to shrink this down a little bit. There's some space underneath. All right. D says, if the weight weighs 19 pounds, the actual force to lift it is 6.4 pounds. What's the actual mechanical advantage? So, AMA equals resistance force over effort force. So what's our resistance force here? 19 pounds. And then 6.4 pounds. And what's our AMA? 2.17. Or 97. And now, last thing, we're going to calculate the efficiency. So we get 3.63 divided by 2.97 times 100%. And what's our efficiency? .82%. That's a terrible percentage sign. That's the answer. Any questions on that? That's because I flipped these around, didn't I? Sorry about that, guys. So this should be 2.97 divided by 3.63. Sorry about that. Now any questions? So now I've got a wheel and axle here, and this means this out here is where the force is being applied. So the wheel diameter is 5.7 inches, diameter of the axle is 5.8. So first thing, A, is this an example of a wheel driving an axle or axle driving a wheel? Wheel driving an axle. Alright, so for B, what's the ideal mechanical advantage? So this is going to be something real similar to what we just did. Because again, the pi's cancel out. So what is our effort distance here? 5.7 inches. What is our resistance distance? 1.8 inches. So that's that equal, and you divide that out. 3.17 for our ideal mechanical advantage. So C, if the effort force is 15 pounds, what's the ideal maximum weight that can be lifted? So this time we're going to say IMA equals resistance force ideal over effort force ideal. So we get 3.17 equals FRI is what we're looking for here, right? Yep. And that's going to be over 15 pounds. Multiply 3.17 by 15, we get FRI equals what? 47.55 pounds. And what that means is that with this wheel and axle, if you applied 15 pounds, the maximum weight you could possibly lift is 47.55 pounds. But it's going to be something less than that because you're not going to have an ideal machine. And the efficiency is not going to be 100%. Yeah, it's pounds, because you have pounds here times 3.17, you still end up with pounds. Right. D, if the effort force is 15 pounds, the resistance force is 41.5 pounds, what's the actual mechanical advantage? We're going to say AMA. What's our resistance force? 41.5 pounds. And our effort force is 15. And what does that equal when we divide that out? So that's our AMA. And last one was the efficiency. And it's AMA over IMA times 100. And I'll do it right this time. So 2.77 divided by 3.17 times 100%. And what's our efficiency? All right. Any questions on that one? Okay, number 3 says, if the pulley is being used to lift a 21-pound weight, what is the ideal effort force? All right. First thing we need to figure out for this one is what is the ideal mechanical advantage of this pulley system? 2. So we've got, 1, 2 that are not being pulled down, or that are going against the weight being pulled up. So our IMA is 2. And we're looking for the ideal effort force. We're going to say IMA equals ideal resistance force over ideal effort force. We get 2 equals 21 pounds is our resistance force. That's a terrible. So what we're going to do is multiply both sides by the ideal effort force and divide both sides by 2 to figure that out. So we end up with ideal effort force equals 21 over 2. And what is our ideal effort force? 10.5 pounds. Alright, any questions over this one? Alright, why don't you guys try doing the last 5 on your own. I'll come around and help you if you need it.